Welcome to our hands-on course on developing Extended Detection and Response, or XDR, and Endpoint Detection and Response, or EDR, systems from scratch. In today's complex threat landscape, understanding how these critical security tools are built is more important than ever. We'll explore the fundamental architectural evolution from the siloed, endpoint-focused view of EDR to the holistic, enterprise-wide visibility provided by XDR. This journey will equip you with the foundational knowledge to engineer modern defensive systems. Our first step is to understand the architectural mandate driving the shift from EDR to XDR. Endpoint Detection and Response fundamentally transforms security by focusing on continuous, real-time monitoring at the host level. EDR agents collect detailed telemetry like process activity and file system changes, allowing them to spot suspicious behaviors that traditional antivirus would miss. However, EDR's primary limitation is its narrow, siloed view. It struggles with modern multi-stage attacks that move laterally across the network or into the cloud, creating significant blind spots. This is where XDR comes in. Extended Detection and Response evolved from EDR to solve this problem. It unifies telemetry from multiple security layers: endpoints, the network, cloud environments, email, and identity systems. By consolidating these signals into a single control center, XDR provides the comprehensible visibility needed to detect complex attacks, streamline incident response, and finally overcome analyst alert fatigue. Next, let's design the heart of our system: the cross-platform agent. The choice of programming language here is a critical security decision. While languages like C and C++ offer high performance, they come with a significant cost: memory safety issues. These weaknesses are actively targeted by adversaries to compromise the agent itself. This is why Rust is increasingly the preferred language for safety-critical systems programming. Rust provides the speed of C++ while eliminating entire classes of memory safety bugs at compile time, making it the ideal choice for privileged kernel components. For the agent's user space services and the backend data pipeline, Go is an excellent complement. Its powerful concurrency model is perfect for handling the high-throughput data streams our agent will generate. We also have to consider where our code runs. Kernel mode gives us the highest level of privilege, but a single flaw can crash the entire system. Recognizing this, modern operating systems are pushing developers towards more stable, managed APIs that run in user mode, enhancing both security and reliability. A truly effective agent must be cross-platform, which requires mastering the unique, native telemetry APIs of each major operating system. There is no one-size-fits-all solution here. On Windows, we rely on two key technologies. First, Event Tracing for Windows, or ETW, which is a highly efficient, low-overhead facility for consuming system events. For preemptive control over file operations, we use mini-filter drivers. On Linux, the modern standard is the Extended Berkeley Packet Filter, or eBPF. This revolutionary technology allows us to safely run sandboxed programs inside the kernel itself, using hooks like kprobes to trace system calls with incredible performance. And finally, on macOS, Apple has deprecated traditional kernel extensions. The modern approach is the Endpoint Security Framework, or ESF. This is a user space API that allows our agent to subscribe to security events, either to authorize actions before they happen or receive notifications after. Each platform presents a different set of rules and security boundaries that we must respect and engineer for. To conclude, building a modern EDR and XDR system is a journey of mastering low-level, platform-specific interfaces. From the privileged world of Windows ETW and drivers, to the high-performance kernel programming of Linux eBPF, and finally, to the managed user space paradigm of Apple's Endpoint Security Framework. The ultimate goal is to collect this rich telemetry, transport it to a scalable backend, standardize it, and apply sophisticated analytics to generate high-fidelity detections. But where is this all heading? The future of security is agentic. Imagine autonomous AI agents with distinct roles, capable of simulating attacks, proposing countermeasures, and automatically testing your defenses. The XDR platform we've outlined today is the critical data and orchestration backbone required to power this next generation of proactive, adaptive security. This course will give you the skills to build that very foundation, preparing you for the